Hello, good evening and welcome to another session of quadrilaterals. In the last session I discussed few of the problems of quadrilateral with you. Today I'll be discussing some more problems of quadrilateral and also the converse of midpoint theorem. Midpoint theorem I have already discussed in the last session. Now in this session I'll be discussing the converse of midpoint theorem and few of the problems. Let me first of all remind you that this presentation is brought to you by Pratna Society, a society which is always engaged in saving the life of poor and needy peoples. So it's my request to subscribe to the channel so that whenever I upload any video you get the direct notification of it, and always try to help others and needy ones. You can contact us at our WhatsApp number, which is written on every slide, that is 745684065. Now coming back to quadrilaterals. First of all, let's discuss the converse of midpoint theorem. Midpoint theorem in the last session we discussed is that any line which joins the midpoints of two sides of a triangle is parallel to the third side and is half of it. So that is the midpoint theorem. Now converse of midpoint theorem: if a line is drawn through the midpoint of one side of a triangle and parallel to the another side, it intersects the third side at its midpoint. It bisects the third side. That is, supposing this is a triangle ABC and this is the midpoint of side AB, that is D is the midpoint of side AB, and a line is drawn which is parallel to DE is the line which is drawn parallel to BC, then we have to prove that AE is equal to EC. AE is equal to EC, that is E bisects the side AC. We have to prove that. This is called as converse of midpoint theorem. Now how can we prove this? Just look at this. We draw a line like this. A line which is parallel to AB. We draw a line which is parallel to AB and extend it to this point. Supposing this is G. Now join AG. Join AG. Now we have constructed a line that is parallel to AB. CC is the line which is parallel to AB and it is equal to AB. Parallel to AB and equal to AB. Right? So now to prove, we have to prove that E is the midpoint of AC, or we can directly prove that AE is equal to EC. AE is equal to EC. We have to prove this. Now extend this line also. This one like this. So this is also parallel to BC. Now in this quadrilateral BC FD, BC FD in quadrilateral. FD other. BCFD. We have drawn this line CF parallel to BD. CF is parallel to BD by construction. Similarly, it is given that BC is parallel to DE, so BC is also parallel to DF. BC is parallel to DF. As DE is parallel to BC. DE is parallel to BC, so DF is also parallel to BC. Now, since two pair of opposite sides, that is BC is parallel to DF and BD is parallel to CF, two pair of opposite sides are parallel, therefore BCFD is a parallelogram. BCFD is a parallelogram. That is because two pairs of opposite sides are parallel. Therefore, it is a parallelogram. Now, since this is a parallelogram, therefore BD is equal to CF. BD is equal to CF. Since they are opposite sides of parallelogram. Now we know BD is also equal to AD, but AD is equal to BD. It is given. AD is the midpoint. Midpoint of D is the midpoint of AB. Therefore, AD is equal to CF. This line AD, this one, is equal to CF. Now, in triangles, ADE, triangle ADE and triangle CFA. ADE and CFE, we know that AD is equal to CF. Just proved above. Second thing, we know that angle 1 is equal to angle 2. They are vertically opposite angle. Angle 1 is equal to angle 2, vertically opposite angle. And the third thing, this angle 3 is equal to angle 4, this one. Angle 3 is equal to angle 4. Since this line AD is parallel to FC and DF is transversal. Angle 3 is equal to angle 4. AD is parallel to CF and DF is transversal. Therefore, angle 3 is alternate to angle 4. So they are equal. Therefore, the two triangles are congruent. Triangle ADE is congruent to triangle CFE. And when these two triangles are congruent, therefore AE is equal to EC. AE is equal to EC by CPCT. Now, as these two triangles are congruent and AE is equal to EC, therefore E is the midpoint of AC. E is the midpoint of AC, and this is what we had to prove. Now let me explain this once again. Converse of midpoint theorem. If a line is drawn through the midpoint of one side, of a triangle and parallel to another side, then it intersects the third side at its midpoint, or we may say that it bisects the third side. Now we have to prove that E is the midpoint of AC. To prove E as the midpoint of AC, what we have to do is that we have to do a construct a line CG such that CG is parallel to AD and CG is equal to AD. Now join AG. After joining AG, we draw this line DE and extend it to F such that it cuts CG at F. Now, since BC is parallel to DE and DF is extension of DE, so DF is also parallel to BC. Now, BD is parallel to CF. This we have done through construction. BC is parallel to DF and BD is parallel to CF. Therefore, it is a parallelogram since two pair of opposite sides are parallel. This is parallel to this and this is parallel to this. So two pair of opposite sides are parallel. It is a parallelogram. Now since it is a parallelogram, the opposite sides are equal. Therefore BD is equal to CF. BD is equal to CF. But since BD is equal to AD, therefore AD is also equal to CF. Now we take these two triangles, triangle DADE and CFE. These two triangles, this one and this one. In these two triangles, we know that AD is equal to CF. We have just proved it. Then second thing, angle 1 is equal to angle 2, vertically opposite angle, and angle 3 is equal to angle 4, this one. Since these line AB and GC are parallel and DF is transversal, so these are alternate angle. Angle 3 is alternate to angle 4, so they are also equal. Therefore, the two triangles are congruent, and they are congruent by AAS rule of congruency. Since these two triangles are congruent, therefore AE is equal to EC, or we can say that E is the midpoint of EC. So this is how we go through the converse of midpoint theorem. Now we take few problems. First of all, problem 1. In the given figure, AB is parallel to CD